you're expected to be able to take a chemical equation and write out or model what's happening at the molecular level. So in a chemical equation, the left side of the arrow is the before, also known as the reactants. The right hand side is known as the products. And that is after the chemical reaction has happened. So when we're trying to model what it looked like in the beginning, we've got Mg that's a solid and O2 that's a gas. So let's start with the magnesium. In this example, magnesium's going to be modeled with a square. So if I want to show a solid, I want to show them connected together. That's why I'm drawing the squares right next to each other. I can draw any number of magnesiums that I want. I'm going to choose to draw an even number. I'm going to draw 12 magnesiums. You can draw any number that you want. I'm showing them organized, neat structure. This is magnesium and it's a solid. Now I just need to model the oxygen. I'm going to do this by using the key. Oxygen's going to be the black circles. So the black circles, oxygen with the equation is shown as O2. So I have to draw two of them connected to each other. But it's in the gas state. So instead of showing them all clumped together, I'm going to show O2 molecules floating around the magnesium. This represents the oxygen that's in the air. And I want enough oxygen that I can react with the magnesium. For every one magnesium I drew, I want to make sure that I draw an oxygen atom. Now, I've now drawn 6 molecules of oxygen, which has a total of 12 atoms of magnesium. I'm going to show this. I want to conserve all of the atoms, so I'm going to draw the after now. If we go back up to the equation, the after, or the product, is MgO, and it's in the solid state. The ratio is 1 magnesium to 1 oxygen. So I'm going to draw a solid, and when I draw it, for every 1 magnesium I draw, I'm going to draw an oxygen, and I had a total of 12 magnesiums, so I'm going to draw 12 magnesiums down here. And that's to show that, or illustrate the idea that matter is neither created nor destroyed. It's only rearranged. I've got a 1-to-1 ratio of magnesium to oxygen, and I'm showing them in a regular structure to indicate that it's a solid. I've drawn 8 magnesiums now, so I'm going to finish up by drawing a total of 12 magnesiums, and then my oxygens are going to be drawn in here. And symbolically, this, what I drew, is a solid, MgO. So these represent the before of this reaction, and after the oxygens have combined with the magnesium, we get the afterwards.